You have n tiles where each tile has one letter tiles I printed on it. Return the number of possible non-empty sequences of letters you can make using the numbers printed on tile. So why is this 188? I guess this is unique, right? So let's do, right, width is length of tiles, and then let's do for I in range 2 to the width, and then for j in range width, and then if I is j, so this is just generating a bit mask if it's odd. 'Too many S's. Okay, unique tiles dot add s, and then return length of unique tiles. So then for each number, I would scan and then create a string, and then so in all bit masks, I'm gonna go through every single combination, but then because there's repeated letters, you might have cases where it's like, well, there's 3A, so you might have like AABBCA and then AABBCA, but then it's different. Actually not sure though, why is this 188? Where's the repetition coming in? Why isn't this 1, 2, 3, 4, 5, 6, 2 to the 6 power? Here are a number of possible non-empty sequences of letters you can make using the letters printed on those tiles. Yeah, I don't quite get why this is 188, because 2 to the 6, because I was just, why not just return 2 to the length of tiles? Why is this 188? A possible of non-empty sequences of letters you can make printed on those tiles. I guess I don't really know what the problem definition means if this is 188. Because if anything, because you have all different orderings of this. I see. So the order does matter, whereas with this, the order doesn't matter. Permutation formula. this is 8 because 3 choose 1 plus 3 choose 2 plus 3 choose 3. Or if it's permute, then it's like minus. How do I represent this in combinatorics? Number of objects selected. Let's say I choose 2 objects, 6. And then, but that's 9. Oh, because then it drops the unique. Okay, I think then probably need to do recursion. Huh. What? What the I don't get it. Let me do like that. I just want to print something so I can move on to the next solution. I don't get it. Why is tiles 0? What the fuck is going on? Oh. Yeah, but I mean, it's still not printing. Oh, it's J. Okay, that looks better, but it's wrong. So, cool. Alright, now I need to permute. Everything, so if I have a base case of A, B, then each of these is 1. Probably have like a global set, and if I'm at the lowest depth, I would just plus equals 1 because not unique, and then in the next level I would just add. This. Okay. So if tiles because it's guaranteed to be unique if there's a single element. Otherwise, the lower one recurs. And then I'll do what? Depth minus 1. So in each depth, what I want to do. So let's say I get this A and I'm on the second level, then I want to be able to loop against um yeah, for letter in lower, I'm at depth 2. So for letter in lower, I want my tiles I plus. Tiles 8A, like So I want to recurse it so it's not my thing. So if I'm depth 3, then so skipping I. So here, if I'm level, if I just have A, B, then my depth is 2. 2 is the depth, and then I go depth 1, and I return stuff. And then so for like if this I is referring to A, then it'll pass this B, and I get B, and then for letter, I'll just do this, and then add it back in. Just to be safe, but I don't think this will repeat. Oh no, yeah, because the letters can repeat. So this indexing isn't, the lexicographical indexing isn't enough because you can have a different index of the same letter. And then so I'll have like ABBA on the 3rd level. I would have ABBA, and I'll add this A in, or I'll add B in, yeah. Okay. What? Length of tiles is 1, so... Oh. It's persistent through... Okay. Didn't know that. Okay, next. An array paths, where paths is this? Okay. One of 4 types of flowers. Um... So it's like BFS plus DP, I guess. If path with different color. So if node J are connected to node I, and then B also C, then A is like 1, B is like, B, C, D is like 2, but then B and C are connected. I'll iterate through B, and then I'll say C is now 3. And then can I do this without accidentally coloring. Yes, this is fine. So this guarantees A will have different color than neighbors, and guarantees B will have different color than neighbors. So C will be different than A and B, because we're just we're just going from 1 through 4, or like the next color of B, basically. So if B was 1, this would be 2, and then basically this only breaks if there's more than 3 paths to A, because if B is connected to C, then C is the third color, and let's say C is connected to D, which is connected to A, then D would be the fourth color. And then this will only break if there's such a to E, but then the problem, it says that the path is not gonna be more than 3. So yeah. Yeah, I think I will do this, waste some memory. Yeah. Because if I do a search, I don't want to go back. And yeah. Let's see if this prints. Be cool. Okay. So I want to mark from to visit it, yeah. What do I want to do here? So I want to do A, and I want to color A. So what colors are there? 1, 2, 3, or 4. So maybe I just want to say, just initialize with color 1, and then, yeah. So now, you know, well, I guess that we don't have to start one. So for from path in path, so for example, let's say I start 2, 3, then I'm going to exhaust this in this iteration, so then I'll just go add the from path to here. Or perhaps I should add it to here. And then so if the to path is not visited, so this initializes it. No, but then this would overwrite all these other ones. So how do I want to do this? So I mark this as 1, and then for all these neighbors, if to path not in visited, then if to path is the same as the colors in the from path, then go ahead and change the colors of the to path equals colors of the from path plus 1. And colors of from path is 0, meaning it's non-visited in the sense that I haven't exhausted it, but it also shouldn't be visited from a previous neighbor. So like this is a brand new node that we have not explored, so just color it 1. And if we haven't visited or colored it, it means this is a completely isolated node. So we can start 1, I think. Can we? Yeah. So this does this for A, and then A will have different colors than its neighbors, because for the to paths, if it's not visited, I'll go ahead check it's 0 if it's 0, or if it equals, then it'll go ahead and increment that thing. path isn't 4 else 1, because if it's 4 already, then there's no plus 1. So then this will go ahead and color, B, C, D with 1, and then A is visited. So let's say the other path is like B to C, so then my from path is B. B is not invisited, but the color isn't 0, so we're not going to go ahead and overwrite it with 1, so overwrite the 2 with 1. And then so for it'll basically look at C, and C is not invisited either. It's not 0, but then the color would be the same, so anchoring it by 1, and so on and so forth. I guess my main concern is like if there's like another island that I didn't visit it, I start at 1 and then I connect it with something else, that might not be great. Let's try. So there's a 10,000 nodes, but there's no paths. Oh, I see. So if there's no paths, there's nothing to color. So if there's no paths, return 1 times n. Oh, I see. Okay. These are islands that's never been visited. Okay, well this is pretty hard to debug. Let's see. I just want to see the okay, yeah. I think that's good enough. I just want to see how much. Oh, I mean, yeah. You probably track an interview with this, so all good.